12th subject mathematics. Unit differential calculus topic differentiation formulae for inverse trigonometric functions. So today we will discuss how to differentiate sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x with respect to x, and later on we will use them directly in the questions. First, derivative of sin inverse x. Let y equal to sin inverse x. We can write it as x equal to sin y. Now differentiating with respect to x, derivative of x with respect to x is 1. Sin y is cos y. Y with respect to x is dy upon dx. Chain function. So I have discussed before this chain rule. So dy upon dx is 1 upon cos y, or dy upon dx is 1 upon under root 1 minus sin square y, because sin y is x. So we have to write our answer in terms of x only. Y just we have assumed. So it is 1 upon under root 1 minus x square, that is d upon dx of sin inverse x is 1 upon root 1 minus x square. So this has become a formula for derivative of sin inverse x. Second example, differentiate tan inverse x with respect to x. Same way, let y equal to tan inverse x, x equal to tan y, differentiating with respect to x. Derivative of x is 1 with respect to x. Tan y is sec square y into dy upon dx. Therefore, dy upon dx from this equation is 1 upon sec square y, which is 1 upon 1 plus tan square y over 1 upon 1 plus x square. Or d upon dx of putting y as tan inverse x we had assumed is 1 upon 1 plus x square. So similar formula we can derive for cos inverse, cot inverse, sec inverse and cosec inverse x. Derivative of cos inverse x is minus 1 upon under root 1 minus x square. Derivative of cot inverse x with respect to x is minus 1 upon 1 plus x square. Derivative of sec inverse x with respect to x is 1 upon x under root x square minus 1. And that of cosec inverse x is minus 1 upon x under root x square minus 1. Now there are some direct applications of these formulas. Like here I have written example 1. 5 examples I have taken. Sin inverse x square differentiate with respect to x. So the answer is, there are two chains. One chain is sin inverse and other is x square. So first derivative of sin inverse x is 1 upon under root 1 minus x square, where x is x square. So x square is square by sin rule, inverse rule, and then derivative of x square, second chain. So after derivative of x square it is 2x, and it is 2x upon under root 1 minus x square. Similarly, tan inverse e to the power x. So tan inverse x is 1 upon 1 plus x square. X is e to the power 2x. That is why it is 1 upon 1 plus e to the power 4x. Then derivative of e to the power 2x is 2 e to the power 2x. The final differentiation is 2 e to the power 2x upon 1 plus e to the power 4x. Differentiate sec inverse 1 upon x with respect to x. So x is here 1 upon x. So it is 1 upon x under root x square minus 1, and after simplifying it is 1 upon under root 1 minus x square. Derivative of cot inverse log x. So cot inverse x is, derivative of cot inverse x is minus 1 upon 1 plus x square. X is replaced by log x. So log x square, and derivative of log x, second chain, 1 by x. So that is your answer. And cosec inverse x cube to differentiate with respect to x. So first derivative of cos inverse x is minus 1 upon x under root x square minus 1. X is replaced by x cube in the formula, and then derivative of x is 3x square. The answer is 3 upon x. Here x square, x cube cancels, then x is left. So minus 3 upon x under root x to the power 6 minus 1. So that is all. Similarly you can apply it to the exercise.